first of all, the electric current, we can say that electric current is the flow of charges per unit time. Charges we can write as charges is Q, per unit time is known as electric current I. We can define as the electric current is expressed by the amount of charge flowing through particular area in unit time. In other words, there are two types of electricity. Yes, it is the rate of flow of electric charges. Two types of electricity: conventional current and electron flow. The conventional current is the flow of positive charges, and the direction is the flow of positive charges. Flow of positive charges was taken to be direction of electric current, and the electron flow is opposite to the direction of conventional current. So we can write the electric current I is equal to charge Q by T, and define 1 ampere. The unit of electric current I is ampere, and charge unit is coulomb. Time SI unit is second. So we can define 1 ampere is equal to 1 coulomb per 1 second is 1 ampere. The electric current is the ratio of charge per time, or ratio of charge and time. Yes, if a net charge Q flow across any cross section of a conductor in time t, then the current I through the cross section Q by T is Q by T. So I is equal to Q by T. The SI unit of charge is coulomb. C, the denoting letter is C, which is equivalent to the charge contained 6 into 10 raised to 18. That means how many electrons are present in 1 coulomb. We can easily find that is 1 ampere is okay. We not use this. We can find charge, other property, charge Q is equal to N. Charge is quantized, so N is equal to, charge is the integer multiple is Q. Okay, N is equal to Q by E. That is how many electrons are present. Yes, okay. 1 coulomb divided by 1.6, charge of electron is 1.6 into 10 raised to minus 19. This will be get it 6.2 into 10 raised to 18. Yes, how to measure the electric current? We are use the instrument is called the ammeter. The ammeter is connected series in the circuit. Series arrangement means end to end connection. End to end connection is called a series. In this circuit, the conventional current flow from positive to negative. The switch is on. The ammeter is connected series. So this instrument is used to measure the electric current. So the electric current flow in the circuit from positive terminal to of a cell to negative terminal of a cell through the bulb and ammeter. We are saying, okay, we are find the flow of current. That was a problem. I, flow of current is given 0.5 ampere, and the electric bulb T is given, T is 10 minutes, and the amount of charge we can find Q. We use the equation I is equal to Q divided by T. So we put the values of this equation. Q is not, T is 10 minute, 10 into 16 multiply, and I is given, I is 0.5. 0.5 is equal to Q divided by 600 seconds, and we cross multiplication, 0.5 into 600 is equal to Q, that is 1 point is here, 300 is answer, 300 ampere. And these are the answer. What is next topic? What is electric potential and potential difference? We know that the electric potential. What is the electric potential? Volt. We familiar the name volt. Yes, the electron move only if there is difference of electric pressure. The electric pressure is called potential difference along the conductor. That means the electric pressure to move the charges, move the electrons. So is the difference of electric pressure. We say that the difference of electric pressure is the electric potential difference. The electric potential difference between 2 points in an electric circuit carrying some current as a work done to move a unit charge from one point to other. Yes, we can define the electric potential P is equal to W divided by Q. That means potential is the electric pressure difference. That means the movement, electrons move only if there is a difference of electric pressure. That means when we are considering two levels, two height of water, same container, same, these are the 5 ml water containing container, and these are the 5 ml water container at a different height. When these are the open end, when this height, which beaker to move the water, beaker A and B, the water move from A to B. That was these have high potential. These have the low potential. So the water must move from high potential to low potential. These have a difference in the pressure variation, in the water level variation. So these have a difference. Is same idea are in the case of electric potential difference. So the electric pressure variation, the electron move only if there is the difference high potential to low potential. That was the idea. The electric potential difference between 2 points in an electric circuit carrying some current. The work done, we can simply define as work done to move a charge from one point to that point is called electric potential. That we can define as electric potential V is equal to W by Q. W by Q is the W is the work and Q is the charge. Yes, the potential difference between 2 points, work by charge. The SI unit of work is joule and charge is coulomb. And the SI unit of electric potential is volt, and name after the honors given to the scientist. His name is Alessandro Volta, an Italian physicist. So the SI unit of electric potential is volt. 1 volt is the 1 volt 1 volt is equal to 1 joule per 1 coulomb. Coulomb is a unit of charge, and work unit is joule. These are the dimension of 1 volt. Yes. The other is circuit diagram. The potential difference is measured by using the instrument is called a voltmeter. The circuit diagram is open and closed. It's open-ended. These are the open-ended circuit. These are the closed-ended circuit. The instruments, the electrical components are represented by some other symbols. These symbols are an electric cell. The symbol is this. A battery or combination of cell. 1 cell, 2 cell, 3 cell are connected linearly, seriously. Plug, switch. These are the open switch. These are the closed switch. Wire join. These connection. These symbol. Wire crossing without joining. Or this connection, this symbol, and electric bulb, and a resistor symbol, and variable resistor. These are the rheostat. Variable resistor symbol is these are the variable resistor, and this end is in the rheostat. Ammeter, positive, negative, voltmeter. These are the symbols of various electrical components. And very important law is called Ohm's law. When a current flowing through a conductor, their potential and current relation connecting law is Ohm's law. So the current flowing through a conductor I is directly proportional to the voltage at the end of the conductor is Ohm's law. The law is derived by the scientist, German physicist George Simon Ohm. Found out the relation between current I and flowing in a metallic wire and the potential difference across its terminals. The potential difference V across the end of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided the temperature remain same. This is called Ohm's law. We can define the V is directly proportional to I. So the proportionality, we will change the proportionality. V is equal to, the proportionality constant is R, Ri. Yes, these are the first equation, very important equation. And we can find I is equal to V by R is equal to V by I. These are the basic 3 very important equations for the further classes, and very important. I is the current, and V is the volt, R is the voltage, V is the voltage, R is the resistance. So some other factors are depending on the current flowing through a conductor. Yes, R is constant. Yes, the R is constant for a given metallic wire at a given temperature and is called a resistance. It is property of a conductor to resist the flow of charges. It resists the current. That is called a resistance, and its unit is ohm. The honor of George Simon Ohm, the unit is given as ohm. If the potential Ri. One ohm, sorry, that we get R is equal to V by I. 1 volt, the SI unit of voltage is 1 volt per 1 ampere. Yes, that is the 1 ohm. Okay, these have a division. The current through a resistor is inversely proportional to its resistance. Yes, current is inversely proportional to the resistance. I is equal to V by R. That means I is equal to V divided by R. That means resistance decrease, current increase. Resistance increase, current increase, current decrease. That was the relation. A component used to regulate current without changing the voltage source is called variable resistor. That is, regulate the current without change the voltage. The variable resistor is used in the circuit. In an electric circuit, a device called a rheostat is often used to change the resistance in a circuit. Rheostat is the major component to control the resistance of the circuit. Factor on which the resistance of a conductor depends. Resistance of a conductor depends on its length L and area of cross section and on a nature of material. So we can, R is directly proportional to L and R is inversely proportional to 1 by area. Area increase, resistance decrease. So we can say write as R proportional to L by A. R is equal to rho into L by A. Rho is the resistivity and proportionality constant. The rho is equal to RA by L. RA by L. That is rho is the resistivity. Yes, where rho is a constant of proportionality and is called the electrical resistivity of a material of the conductor. Resistivity is different for different material. That is, resistivity is constant for each and every material. The SI unit of resistivity is ohm meter. Rho is equal to VR defined. Rho is equal to RA by L. Ohm resistance unit is ohm, area unit is meter square, length unit is meter, that these are cancelled, and ohm meter. It is a characteristic property of the material. Some other metal and alloy very low resistivity, the range 10 raised to minus 8 to 10 raised to minus 6 ohm. That is only in the conductors, the metals, alloy, and very low resistivity material. Resistivity range 10 raised to minus 8 ohm to 10 raised to minus 6 ohm. Insulator like rubber and resistivity of water, the very great resistivity, that is 10 raised to 12 to 10 raised to 17 ohm meter. The resistance and resistivity of a material vary with the temperature. The temperature is increased, the resistivity decrease. That was the temperature and resistivity material's character. Yes, series and the combination of, we are discussed the resistor in series arrangement and resistor in parallel. Resistor, the series means end to end connected in a component is called series arrangement, or linearly the components are arranged in a linear manner is called series. Series combination of resistor, the current is the same, the voltage is different. Voltage is different, the current is same and voltage is different. Every part of the circuit or the same current through each resistor. These are connected by battery. The positive to negative current are moving. So the resistor are connected one by one. The three resistors are here. The across the potential across the resistor find by using the voltmeter V1, V2, V3. Their potential is different, we know that. So the current I is equal to V by R. I is equal to V by R, we know that. Is equal to V by R, we know that. V is equal to IR. We use this equation. The R1 R2 resistor, R1 resistor across the voltage V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. These are the voltage across R1, R2, R3 resistors. Finally, total sum of the series resistors voltage is V1 plus V2 plus V3. Thus we can write as V is equal to IR1 plus IR2 plus IR3. Yes, we can write V is equal to IR is equal to I is common, so we outside I, we take outside, and R1 plus R2 plus R3. So this I and this I will be cancelled. The R is equal to R1 plus R2 plus R3. The effective resistance of R effective RS series resistor is R is equal to R1 plus R2 plus effective resistance R1 plus R2 plus R3. So these equations are here. In a parallel type resistor, 1 over 1 resistor are connected 1 over 1, that means these over R3 over R2, R2 over R3, this type of arrangement is called the parallel type resistor. Parallel type resistor specifications means their voltage is same but current is different. So we can find the current I. Yes, find out the I is equal to V by R. That was the equation. The R1 resistor current is I1 is equal to V by R1, and I2 is equal to V by R2, I3 is equal to V by R3. So finally find the total current I parallel IP is equal to I1 plus I2 plus I3. IP we can write V by R is equal to V by R1 plus V by R2 plus V by R3. So we can outside the V is same, V by R is equal to V is outside 1 by R1 plus 1 by R2 plus 1 by R3. So this V will be cancelled out, and finally we get 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So these are the parallel type resistor effective resistance of a parallel type resistor. These are the effective resistance. One by are the heating effect of electric current. When a current flowing through a resistor contained circuit, the current flowing after some time the resistor will be produce heat. So the heat is the form of energy. That means the electrical energy is converted to heat. that means the energy dissipation are here. The electrical energy converted to some type, some part of electrical energy is converted to heat energy in this circuit. So the power, the energy is equal to, energy is work by time. Energy, work by time is energy. So work is, we know that work is the VQ is equal to VQ by T. So we can write I is equal to Q is equal to IT. We put the equation VIT by T. These will be cancelled. The answer is VI, energy or power. Power is equal to VI. We can say that VI. And the energy supplied to the circuit by a source in time T is power into T, that is VIT. Thus the steady current I, the amount of heat H is produced, that means H is equal to VIT. We can write H, heat is equal to VIT. So we are applying the Ohm's law. We know that I is equal to V by R. V is equal to Ri, and R is equal to V by I. Put the equation H is equal to, we are put this equation V is equal to Ri, that means Ri in the place of V into I into T, that is equal to H is equal to I square RT. H is equal to, yes, H is equal to VIT. We get the first equation, H is equal to I square RT. These are the equation of Joule's law. And we put the I value, I is equal to V by R. Put the equation V by R, the I whole square RT, that means H is equal to V square by R square into RT. The 1 R cancel, that means we get final answer H is equal to V square by R into T. These are the equation. So the Joule describe the relation between current, heat, resistance. He say that when the conductor and electric current flowing through it, it is stated that the product of heat is directly proportional to the square of the current I and resistance R of the conductor, and time T the current flow is H is equal to I square RT. The current is the produced heat. When a current flowing through a conductor, the produced heat is directly proportional to current I and is directly proportional to resistance and is directly proportional to the time. So we can write as H is equal to I square RT. These are the equation of Joule's law. Yes. What is electric power? The chapter final part is the electric power. We know the energy. The electric power is the work by time. It's a ratio of work and time. Is electric power. Yes. Rate of consumption of energy. We can say that work is energy. So P firstly found P is equal to VI in the previous lecture. The rate at which electric energy is dissipated or consumed in an electric circuit. This is also termed as electric power. The power P is equal to VI. That means that is getted work is VQ by T. We can say that power VQ is equal to IT. We put the equation finally, we get P is equal to VI. So its unit is watt. Watt is a very small unit. 1 watt is equal to, you can say that P is equal to VI watt. 1 watt is equal to 1 volt into 1 ampere. So 1 watt is the energy consumed when 1 watt of power is used for 1 hour. The commercial unit of electrical energy is kilowatt hour, commonly known as unit. 1 kilowatt hour is equal to 1 kilo 1000 into watt into hour. Hour means 60 into 60 second. That means 3.6 into 10 raised to 6 watt second is 1 kilowatt hour, or we can say that joule. 3.6 into 10 raised to 6 joule.